Hello there. In this video, I want to cover how to solve a quasi-symmetric quartic equation. Now, if you watched my video on how to solve a symmetric quartic equation, the method is basically the same, just a little bit more involved. The only thing that we have to know is how to identify a quasi-symmetric quartic equation. So I'm going to write it out in a quartic in a general form so I can show you what we're looking at here. So this is just a general quartic equation, and that E is not Euler's number, okay? We would be able to know this by taking this D value and factoring it. If we can factor D into two factors, B times M, where M is any integer, or I guess rational number, but for the purposes of this video, we'll just talk about integers. And then this B is the same as this B right here. And then we can take our E value, again, not Euler's number, and that would equal A times M squared, where A is the same as our lead coefficient, and this M that I'm squaring here is the same as this M right here. If you can produce that factorization out of the linear and constant terms, then you have a quasi-symmetric equation. So the quasi-symmetric equation I will be working with today is 3x to the fourth plus 2x cubed minus 5x squared plus 6x plus 27 equals 0. Now, again, the approach is to do the same thing as you would a symmetric equation. Let's go ahead and start by dividing everything by x squared. X squared there, x squared there, x squared there, squared there, x squared there. And if you have not watched my symmetric equation video, you're basically getting the full thing here, just a slightly more complicated computation. So we get 3x squared out of this, and then I'll go ahead and take this term, 27 plus 27 over x squared, minus, I'll go ahead and do this term next, that's minus 5. And then we've got x cubed over x squared, that will be plus 2x, okay? And then plus x divided by x squared would be 6 over x equals 0. So I'm going to go ahead and perform a similar substitution. What I'm going to do, note though, is note that a 2 can be factored out here. So I end up with x plus 3 over x, okay? And so let's let u equal x plus 3 over x. Before, in my symmetric video, is x plus 1 over x. Well, if I go ahead and factor out a 3 from here, I get 3 times x squared plus 9 over x squared. Now, once again, we have something here that looks like this squared. So let's go ahead and square u. So we find out exactly what kind of course correction we need to make. U squared would be the quantity x plus 3 over x squared. Now we get x squared from here, and then square 3 over x, that'd be plus 9 over x squared. So far we have that part, okay? And then we are going to go ahead and multiply x times 3 over x, that'd be just 3, and then multiply it by 2, so that'd be plus 6, okay? So let me go ahead and do a quick jump and copy this onto a nice, neat page. Okay, so I've got u here, but remember this quantity over here was 2 times u, so let's make that note. 2u equals 2x plus 6 over x. And then this right here looks like it's 3 times this thing right here, so we'll go ahead and do 3u squared is equal to 3x squared plus 27 over x squared plus 18. So let's go ahead and substitute these in. I'm going to have to put in a plus 18 and then a minus 18 into this right here so that I can simplify everything correctly. So I get 3u squared. This right here will combine. That'll give me a minus 23 and then a plus 2u. Let me put the plus 2u first. So plus 2u and then minus 23 equal to 0. Now, anytime you use this approach, the goal is to get it down to what we have now, which is a quadratic. Then we can either factor if we have the opportunity, or we'll use quadratic formula. This one, we're probably going to have to use quadratic formula, so I'm just going to go ahead and use that. Negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 23 all over 2 times 3. So I got the negative 2 plus or minus, we get 4 out of here, and then 4 times 3 is 12. Then we get 23 times 12, that's 6. 4, drop the 0, we get 3 and 2, so 276. Now that's 4 plus a 276, because we've got a negative here and a negative here. So that's square root of 280 over 6. Okay, so let's remind ourselves that this is u, and let's go ahead and flip onto a clean page. So u equals negative 2 plus or minus the square root of 280 over 6. And let's remember that u is equal to x plus 3 over x. Okay, now let's go ahead and simplify this. The 280 can be broken down into 28 and 10, 7 and 4, 2 and 2. The 10, well, breaking that down won't help. So we get u is equal to negative 2 plus or minus, we get 2, we get 10, so 2 root 70 over 6, and then we'll simplify here, and simplify here. So we get u is equal to negative 1 plus or minus root 70 over 3. Now this is where it gets really hairy, because we've got a very weird looking irrational number that we got to plug into here. So negative 1 plus, I'll start with the plus, 70 over root 3 equals x plus 3 over x, so that we can solve for x. Okay, so let's go ahead and multiply everything by x. I'm going to go ahead and rewrite it. So x squared, this becomes, well, let's see, this would be minus the quantity negative 1 plus root 70 over 3 times x plus 3 is equal to 0. And now we get into really weird territory, because this is where we'd want to use the quadratic formula. So our b value is the negative of a negative, so positive. Our b value is just a positive 1, negative 1, plus root 70 over 3, plus or minus the square root of negative 1 plus root 70 over 3 quantity squared minus 4 times 1 times 3 all over 2 times 1. Let's go ahead and really quickly do a very quick calculation montage. Okay, so that would represent some solutions for this problem. Now, if we remember, this all started with the premise that we went with u is equal to negative 1 plus root 70 over 3. If we then went ahead and went with u is equal to negative 1 minus root 70 over 3. Then this would change to x is equal to -1 minus root 70 plus or minus I root 37 minus 2 root 70 all over 2. And actually, sorry, those should be 6's. That's my bad. Did a very impressive and entertaining montage, and I couldn't even get the denominator right in the end. All right. So let's really quickly go ahead and check Wolfram alpha. Okay, so really quickly, let me show you. There's my original polynomial. And then here are the solutions. Now, they gave me exact solutions, which I'm not used to, but they gave it in a weird way. Notice this square root of 35 over 2 here. They gave that and all that. Well, if you multiply top and bottom by 2, you get 70 over 4 within the radical. Then you can separate them, and square root of 4 is 2. Kick that down here, and you get 1/6, and you get a universal denominator of 6, which is what we had in our solutions. So I don't know why they chose to write it that way. Wolfram alpha does what Wolfram alpha does, but we got the plus and the plus there, and we got the minus and the minus there. Plus, minus, plus, minus. It all worked out in the end. So that's great. Awesome. I was I was worried I was going to have to check that against decimal expansions because that's what I had to do in my cubic formula video. So thank you, Wolfram alpha, for cooperating. Thank you, everybody, for watching.